amazing people, students, and all the lovers of chemistry out there. On today's episode of Question for the Day, we're looking at a question that has to do with one of the three major gas laws. So let's get into what we have today and see if we can do justice to this question. The question says, a gas contained in a steel cylinder has a pressure of 150 kilopascals. So let's go ahead and write out our values or our variables. The first thing we have is the first or the initial pressure P1, which is equal to 150 kilopascals. What else are they telling us? They said, and it has a temperature of 27 degrees Celsius. So the initial temperature, which is T1, is 27 degrees Celsius. What will be the pressure if the temperature is increased to 127 degrees Celsius? So we have the second temperature or the final temperature T2, which is equal to 127 degrees Celsius. And they are asking us, what will the pressure be? So what they're asking us to find is the final pressure, which is P2, which we do not know. So now that we have our variables, it gives us a hint to which of the three major gas laws that applies to this question. Now, if you look and watch very well, you would see with me that the question deals with pressure and temperature. And among the three gas laws, the Boyle's law, the Charles law, and the Gay-Lussac's law, the one that talks about the relationship that occurs between pressure and temperature is the Gay-Lussac's law. And that law states that P1 all over T1 is equal to P2 all over T2. So that being said, we can impute our variables into this formula here and get our answer. So in this case now, remember, in the case of gas laws, we do not use temperature in degrees Celsius. We need to convert our temperatures into degree Kelvin. So for T1, we have 27 degrees Celsius. To convert to Kelvin, you simply say plus 273. When we add 273 to 27, it gives us 300 degree Kelvin. For T2, we have 127 degrees Celsius. To convert it into Kelvin, we simply add 273. When we say 273 plus 127, it gives us 400 degrees Kelvin. So let's impute that into our equation and get our answer. P1 in this case is 150 divided by T1, which is 300. This is equal to P2 in this case is unknown, so we just write out P2 the way it is, divided by T2, which is 400. At this point, we can cross multiply. If we do, it now becomes P2 multiplied by 300 is equal to 150 times 400. Doing that, we have P2 multiplied by 300 is equal to 150 times 400 gives us 60,000. 60,000. At this point now, we can calculate and get the answer for P2 by dividing both sides using the coefficient of P2, which is 300. So 300 here cancels 300 here. What we have is 60,000 divided by 300. So 60,000 divided by 300 gives us P2 is equal to 200 kilopascals, because that is the unit we used for measuring pressure in this question. 200 kilopascals. Now we have solved the answer and we've gotten what P2 is. This is our final answer, but we can go a bit further by checking if our working is correct. Now remember, in the Gay-Lussac's law, it states that P1 divided by T1 is equal to P2 divided by T2. We've calculated everything. P1 is 150 divided by T1, which is 300, And then we have P2. We've calculated P2 to be 200 divided by T2. T2 is 400. Now, if we calculate this part of this equation, it ought to be the same with this part of this equation. So let's go ahead and do a bit of math. 150 divided by 300 gives us 0.5. On the other hand, we have 200 divided by 400. It also gives us 0.5. So from our calculation, we have seen that this obeys the Gay-Lussac's law. So our question that says what will be the pressure if the temperature is increased to 127 degrees Celsius, and we've calculated the pressure to be 200 kilopascal. So that shows that our answer is correct. I hope you saw how every step was carried out. Please do well to like this video, share and subscribe, and I'll see you in the next one.